So I was thinking about how to present these topics to you because I have gone through uh, many videos, I've gone through many PDFs, and finally I found that the material was not really into a lucid manner, and it wasn't really ready for you. So that's why I have recorded this video, which gives you uh, an insight into the underlying concepts of Unit 4. And this video contains a method of numerical integration, its formula, and then two examples based upon that method. So let us start. Unit 4 is about numerical integration and numerical differentiation. We are going to deal with these topics differently. In this particular video, we are going to deal only about numerical integration. There are two methods of numerical integrations in our syllabus. As such, there are several other methods. The methods that we are going to study are trapezoidal method and Simpson's 1/3 rule. In this video, we are going to see only trapezoidal rule. I will shoot another video for Simpson's 1/3 rule shortly. So let us start with trapezoidal rule. The formula and procedure is very simple. So this is basically the formula for trapezoidal rule, and we will see in a moment that how this formula works. Okay, so what we have is integration a to b of y dx. If you want to evaluate this integration from limits a to b, and then there is some function y, there is some variable y whose value is dependent upon x, then we can evaluate this integration numerically using this formula. So we will talk about what is h and what is n. Okay, where h is a step size and n is the number of data points. So generally, while solving a problem on numerical integration using trapezoidal rule, several data points are given, or information of x and y, values of x and y on several data points are given. And let's say if there are 7 data points, then value of n will be 7 minus 1, 6. We will see it shortly. For example, if n is equals to 5, then the above formula becomes. So let us write the formula when n is equals to 5. So that's why I have deliberately put the terms into different colors so that we can understand how to reduce this formula when the value of n is particularly given. So starting with the left hand side, we again have integration from a to b y dx equals to h by 2 as it is. Then let us start with the first green term inside the square brackets, which is y0. So y0 will be as it is. Then when n is 5, then you can see that the term in the blue bracket, in this blue bracket, the last term is n minus 1. Hence, for when n is equals to 5, this term becomes y4. And then finally, the last term in the square bracket, which is in brown color, which is y subscript n, becomes y5. Okay, so let us write the terms in the blue color. So I have y1 plus y2 plus y3 plus y4. Oops, I cannot accommodate all the 4 terms, but that's fine. And finally, the last term is y5. Okay, so that's how this formula becomes when n is equals to 5. Let's take another example. If n is equals to 6, then the same formula becomes again y. Again we start with the green term, so y0 as it is. Then we write terms in blue color. We have 2 into y1 plus and so on up to this time is this. Okay, so this times n is 6, that's why n minus 1 becomes 6 minus 1, 5. And the last term in the square bracket is yn, so n is 6, hence this term becomes y6. Sorry, I have not written the y here. So y5 and y6. So y plus y1 plus y2 plus and so on up to plus y5 and minus 1, and finally the last term in the square bracket is y6. Alright, so I hope you get the mechanics of the formula, and it's very simple. You should be in a position to reduce this formula when n is given. Okay, similarly if n equals to 7, then formula becomes h by 2 in square bracket y0 plus 2 into n minus 1. N is 7, so 7 minus 1 is 6, so y1 plus y2 plus y4. Sorry, I missed y5, so actually this should be sorry, should be plus y5 plus y6, and finally yn is y7. That's the last term in the square bracket. So write it yourself. If you can practice writing that formula of trapezoidal's rule for n equals to 8, 9, 10 and so on. Okay, so let us solve example on trapezoidal rule. Evaluate the integral of the following tabular data with trapezoidal rule. So that's the data given, and you can see that the first row represents value of x, and second row represents value of y or f of x. So basically we know that y is equals to f of x. So the values in the second row are values of y, and values in the first row are values of x, and that is the formula of trapezoidal's rules from the previous slide. So in this formula we have two terms, h and n. So h is the step size, so we know that h is step size. It is the step size. So how the step size is to be calculated? Now if you look at the first row, those are the value of x's, and step size is the size by which value of x increases or decreases. So in this case you see that the value of x, first value of x is 0, and then it goes to 0.1 and 0.2. So the step is of 0.1, so that means we jump by a step of 0.1. So that is the h, 0.1 minus 0, and you will find that the difference between any two consecutive values of x is 0.1. For example, 0.3 minus 0.2 is again 0.1. Similarly, 0.5 minus 0.4 is again 0.1. So that's why value of h is 0.1 for this example. Then n is number of given data points minus 1. So let me erase that. Okay. So now, so how many data points are given? So that is the first data point, second, third, fourth, fifth and sixth. So there are 6 data points given, or 6 pairs of x and y values are given, or we know the values of x and y for 6 different points, and hence n becomes 6 minus 1 equals to 5. Okay. So for this problem, value of h step size is 1, and value of n is 5. So now we want to solve this problem, and it's quite obvious. It will be simply plug and play business. So we'll simply substitute or plug in the values of y in that formula of trapezoidal rule. So uh, let us start. And finally, the formula reduces to this one given here. So we can see that the first value of x is known at 0, or the x starts from 0 and it ends at 0.5. It starts from 0 and it ends at 0.5. So that's why the limits of integration are from 0 to 0.5. Y dx equals to h by 2. So we start with the colors. So first green color, y0 as it is, then 2 into the blue bracket. So the terms go from y1 to yn minus 1, as n is 5 and minus 1 in this example is 4. So y1 plus y2 plus y3 plus y4 plus, and finally brown color, last term in the square bracket, yn y5. Alright, so let us substitute the values. Okay, so h by 2 is should be 0.1. Should have written 0.1, but that's fine. I can still write 0.1. Then square bracket, green color, y0. So if you look at the second row, then we can write the values in the second row actually. So this is y0, y1, y2, y3, y4 and y5. So let us substitute the values. So y0, green color, first term is 1, y1 is 8, y2 is 4, y3 is 3.5, y4 is 5. So terms in blue color, and y5 is 1. And if you do that calculation, it comes out to be 2.15. All right, so you calculate it using calculator, and you should get it to 0.15. So that's it. So that is the value of integration from 0 to 0.5 y dx, and when those are the values of x and y given, then that should be the value of the integration. It should be 2.15. Okay, so this is the same data from the previous slide. This is just for your reference. Let us solve another example, and let me read the example. A solid of rotation is formed by rotating about the x-axis. The area between the x-axis, the lines x equal to 0 and x equals to 1, and curve through the points with the following coordinates. Okay, so there is a curve that goes through those data points, and basically when you rotate that curve, or the area which is constrained by the x-axis, so that is x-axis, that is y-axis, and we have x equals to 0, which is y-axis, this is y-axis, x equals to 0, and x equals to 1, maybe let's say somewhere here. So x equals to 0 and x equals to 1, and maybe there is some curve between these two, and let us say that the curve goes like that. So we are not basically interested in the portion of the curve outside x equal to 0 and x equal to 1. We are simply interested in portion of the curve that is between x equal to 0 and x equals to 1. And what we do is we take this area, this hatched area. Okay, so we take that area and that is just a curve I have drawn. Okay, it does not necessarily represent those data points. It may not be passing through those data points. Okay, it is just to show you how this solid of rotation is formed, and that is the x-axis, which is the axis of rotation. So that is the axis of rotation. So what we do is we take that area and we rotate it around x-axis, and when that area rotates around x-axis, we get a solid. Okay, so we may get a solid of that shape. I cannot really draw it here, but then okay, so we get a solid of revolution. And using trapezoidal's rule, using numerical integration, what we want to do is estimate sorry so estimate the volume of solid form. So if V is the volume of the solid form, we want to know the value of this integration. Okay, so analytically, the volume of the solid formed by rotating that area around the x-axis is given by that formula. So this volume V is equals to pi into integration from 0 to 1 y squared dx. Okay, so that's what we want to find out in this example. So we continue on this slide. Again, we have the same table from the previous slide. So that is the given data from the previous slide, and again we have the formula for trapezoidal's rule. Okay, so let us see how to connect these two things. We have that analytical formula of volume of or solid of rotation, volume of solid of rotation, and we want to calculate this volume using the trapezoidal rule. So V is equals to pi into 0 to 1 y square dx, same thing, and that's our okay, so that's our integration, same thing over here. So what we want to do is, if you try to compare these two things, if I compare this and this, then I need to add few things to this formula. So let me do that. What we want to write here is, this is first of all multiplied by pi, and then we have y square dx. A is 0 and b is 1. Square dividend. So again, if you look at the data points, the first data point is known at x equals to 0. That's why the lower limit of integration is a equals to 0, and the last data point is known at x equals to 1. That's why upper limit is b equals to 1. Okay, so that means if we want to calculate the value of this integration, then we should know the values of y squared. Okay, so let's do that. Let's calculate the value of y squared. So we will not square x's, we will simply square, we'll take a square of y values. So that's the table below. Okay, so table below, so this table indicates the values of y squared. So first value of y is 1, so 1 square is 1. The square of 0.9896 is 0.9793, so you can verify those values using calculator. Okay, so that's the table that contains squares of y's, and that's the formula for trapezoidal rule, and that's how the formula modifies. So we know that the limits for this particular problem are lower limit 0, upper limit 1, y square, and now we substitute the values starting from green term. We know that y0 is 1, then plus 2 into y1 plus y2, so on up to yn minus 1. So what is the value of h and n? Sorry, I forgot to mention h and n. So value of h and n. So h is the step size. So again, we look at the values of x's for step size. Any two values will do. So 0.25 minus 0 gives 0.25. or 1 minus 0.75 also gives 0.25. So that means the value of h is 0.25. And n is equals to number of data points minus 1. So 1, 2, 3, 4, 5. 5 minus 1, 4. Hence n is 4. So coming back to the formula, middle term in blue, 2 multiplied by y1 plus y2, so on up to yn minus 1, n is 4. So this becomes y1, y2 and y3. And finally the last term in brown color becomes y4. Okay. So this should be actually y1. So let me substitute the values. Oops. So let me substitute the values. So y0 is 1.000, y1, so I should write down the values. This is y0, y1, y2, y3 and y4. So blue color, 2 into in bracket y1 is 0.9793 plus y2 is 0.9195 and y3 is 0.8261 and last term in brown color is 0.7081. Okay, so you calculate this term and finally we'll get some answer. So then the value of volume of solid of revolution becomes pi into 0 to 1 y square dx. So this should be multiplied by pi. So pi into that value. So this value basically it goes here, and the final answer is 2.8109. Final answer is 2.8109. And that term here is 0.8 something, so you calculate it on the calculator and finally you should get the result. Okay. So this is the same problem on the previous slide. This is just for the reference. Finally, I think that there is no much deal about trapezoidal rule. It's fairly simple, it's fairly straightforward. You just take the formula, you have to remember the formula, and then based upon the data points you substitute the values, you modify the formula using the values of h and n given, and in every problem you will be given those data points, and using those data points you should be in a position to calculate the value of the integral. Okay, so solve the practice problems which will be given in assignment, which will be given as an assignment in Google Forms. So I will shortly upload it on Google Classroom, and this assignment will count towards CA2. So I am not planning to have any quiz for CA2. Just the assignments on topics will be there. Okay, so the next video will be on Simpson's rule.